Okay, so I'm just picking back up where I left off, number 5 on the review sheet, factoring. So this is a crazy kind of factoring where we have 1, 2, 3, 4, 5, 6 terms. Something like difference of perfect squares. It's not one of these problems. Something like a basic trinomial. It's not one of those problems where we can kind of guess and check. If there's more than 3 terms, 4 or more, specifically when there are an even number of terms, grouping is your way to go. Now with 6, we could go with 2 by 2 by 2 or 3 by 3, but the groups all have to have the same number of terms. So if I try this first one and pull out a t squared, I'm going to be left with t plus 5. Out of the second group, I can pull out a t, and I'm left with 6 plus t. And on the third group, I would pull out a 1, because there's really nothing there. Now, this did not work, because these don't match. And if they don't match, then that didn't work. So the 2 by 2 by 2 thing isn't going to work. I got to try something else. Try a 3 by 3. So I do 3 by 3. And out of this first group of 3, I can pull out a t, leaving me with t squared plus 5t plus 6. Out of the second grouping, I can pull out really nothing, so a 1. You have to pull out something when you're grouping, so a 1. And that's not going to change a thing when you divide out a 1. And these do match. So now if I look at these as if they're 2 terms, they have the same trinomial. So I'm going to pull that trinomial out in front, and I'm left with t plus 1. Now, this is a traditional looking trinomial. So this I would look to factor further by guessing and checking. I need to multiply to be positive 6, so t and t, and positive 6, so it could be 1 and 6, could be 2 and 3. And I need it to make 5, so 2 and 3 looks good. And now that is completely factored. Okay? One of our infamous directrix problems, sketch a picture. Directrix is at y equals 3. That's our fixed line. And the vertex is at 4, negative 1. Now that's our vertex. So we're either going to bend towards the directrix, which we never do, we should never cross the directrix, or away. So since that's our vertex, we're bending down. And our focus, in order to write the equation, we always need a focus. The focus is always an equal distance away. So this right here is 1, 2, 3, 4 units. So I need to go 4 units down, 1, 2, 3, 4 units down, and there's my focus. So that's going to be at negative, well, 1, 2, 3, 4, so that'll be at 4, negative 1, 2, 3, 4, 5. Okay? And then to write the equation, this is where we do our distance formula, because any point on a parabola needs to be the same distance from the directrix, and we'll call this the point x comma 3, since it's on the line y equals 3. And this is obviously 4, negative 5. So the distance point to directrix needs to equal point to focus. So distance equals a distance. So point to directrix, we'll do x minus x squared plus the y minus the 3 squared. Point to focus, we'll do x minus 4 squared plus y minus the negative 5, which will be y plus 5 squared. So, as always happens, something minus itself is 0, and you'll immediately square both sides, which just loses your radicals. Okay, so your left side is y minus 3 squared. Your right side is x minus 4 squared plus y plus 5 squared. And always 2 of them will be with the same variable, and those are the 2 that we're going to square out. So y squared minus 6y plus 9. Y squared parentheses, y squared plus 10y plus 25. And I solve for y. So subtract y squared from both sides. It's going to cancel those. Here's my equal sign. Get all my y's over to the left, so I'm going to subtract this 10y over. I'm also going to lose this plus 9. So my left side will be negative 16y equals x minus 4 squared plus 16. And I'll divide everything by this negative 16. So that'll be y equals, this I'm never going to break up the parentheses, I'm just going to make that a fraction, 1 over 16. And it's a negative 1 over 16 times my x minus 4 squared. And then 16 divided by negative 16 is minus 1. So there's my, remember my format is this. There's my h of 4 and my k of negative 1. That's my vertex for negative 1. You should use that as a checking mechanism. That's what it was supposed to be. And my a value is negative, which means it opens down, which it does. So that doubly confirmed is my answer. And the last one here, exponential growth and decay. So the formula we use is that our final amount is our initial amount, 1 plus or minus r to the t over rate period. Okay, so first of all, let's figure out what our r was. If this has become 0.81, then we must have subtracted, first of all, 32,000 is our beginning value. We must have subtracted 0.19 to make this whole thing become 0.81. And then t over 12, since t was in months, we have to know that that is also in months. So essentially what we know is that the car value started at 32,000 and lost 19% every 12 months, or every 1 year. So we would say, if we didn't have multiple choice, it lost 19% of its value every 1 year. It started at $32,000. So which statement is not correct? Well, the first one says that the car lost approximately 19% of its value each month. Well, it didn't lose it each month, it lost 19% each year. So this one immediately is false. Okay? Now, to get it to a 1 month rate, if we want to just evaluate the truth of these two, we would just plug in 1. So I would make this and raise it 1 minus 0.19, which is going to be 0.81. I would take 0.81 and I would raise it to the 1/12 power. And that's going to give me 0.98 to the t over 1 month. So if I want to look at it on a monthly basis, I lost 2%, right? This is 1 minus 0.02 technically. So I lost 2%, which means if I lost 2%, I did maintain 98%. So that's correct. The value of the car when it was purchased was $32,000. That's correct. The value of the car 1 year after it was purchased. Now, if I want to go back to the 1 year, I can use this and plug in 12 months, because 12 months is 1 year. So I would plug in 32,000 times 1 minus 0.19 to the 12 over 12 power, which is 25,920 after 1 year, 25,920 after 1 year. So we confirm that 1 is the only one that's not correct.